Hello, we are Team 5. We are going to introduce the voice lab and garter again, which are the main structures of Apple Park. Before that, we'll talk about the information related to the floor plans of Apple Park. So, this is the floor plan of Apple Park. Apple Park is a 4-story building made up of these drawings. The width of this donut-shaped building is 188 feet long, and the area of this floor is 755,000 square feet. The blue part is a office which is covered in glass. The green part is a perimeter circulation where people can walk along a glass window while looking outside. Also, there are shading blade projections attached to the outer glass which can tilt off the sunlight. This is the only restaurant in Apple Park. The restaurant with its huge carved sliding facade elements in steel and glass in the central meeting place in Apple Park, with seating for 4,000 employees. There are 9 entrances so they can enter the nature inside the spaceship at any time. These are air and light shafts which makes Apple Park feel like a part of nature. Now we'll talk about the part of the structure of Apple Park. In Apple Park, each floor consists of void slabs and girders. This is the floor section rendering of Apple Park. As you can see, the red one is the void slab. Between the void slabs, there is a girder. Now we'll get in more deeply with these structures. Steve Jobs emphasized the openness of the space, with all the windows being floor-to-ceiling windows. The office space also emphasized this openness, so the method used was to notch the slabs so that the edge of the windows were not visible, creating an open feeling. The internal structure of the slab is as follows. The metal deck connecting the upper part of the precast is raised, and as the space underneath is hollowed out, a hollow layer is naturally created, and a concrete diaphragm is poured on top of the metal deck. However, with this shape, there was a problem with strong stresses in the red area, as shown in the following image. To solve this problem, a pyramid-shaped hunch was installed, and the final shape of the hollow slab was created. Compared to regular slab, the void slab has a lighter weight. By reducing the weight of the slab itself, these void slabs allowed for wider column spacing and improved seismic performance by providing better resistance to horizontal loads. In addition, the shape of the slab itself automatically creates a beam shape due to the space between the slabs, so there is no need to install additional beams, and the existing space for beams is eliminated, so the floor height can be used more efficiently, maximizing the utilization of space, which further achieves the openness of the space that Steve Jobs wanted. Also, due to the hollow inside the void slab acts as an insulator, the void slab has a 30% higher insulation performance than a regular slab. In addition, radiant cooling tubes run inside these slabs used in Apple Park. These tubes were able to reduce the temperature by 6 degrees Celsius during the day and 11 degrees Celsius at night without any power. The tubes and the hollow slab were a great support for Steve Jobs' idea of minimizing the use of cooling systems such as air conditioning. The following figure shows the overall cross-sectional shape of the ceiling. The full slab model would be the bottom part, and the empty space above will be used for plumbing and other pipes. So let's go to the next part, girder. The girder and wall edges were designed for the concentrated reactions. In Apple Park, the inverted T-girders were used to achieve the following objectives: large span capability, efficient load distribution, ease of installation, and reduced structural heat. Also, the post-tension beam construction method was used. Apple Park chose to use post-tension girders because of these four advantages. First, the flexibility in field application. Post-tensioning adapts seamlessly to complex and large-scale structures directly on site. Second, it allows for tension adjustments after construction, accommodating changes in loads and maintaining structural integrity. Third, post-tensioning can apply greater tension, supporting larger loads and extending the spans of structures. And lastly, it enhances design freedom and improves overall structural performance, encouraging innovative construction solutions. The void slabs rest on ledges of precast post-tension girders or on a continuous ledge at the shear wall lines. The support connection chosen was a truss hanger bar, a rectangular steel bar with welded inclined rebars that transfer the reaction into the stems of the units. These girders repeated themselves at every interior radial grid line. The girders also had to perform as collector elements, delivering more than 400 kilopounds of force to the shear walls. The surface space below the girder was shrouded with either an architectural beam cover or partition framing where walls were placed. So why they chose these structures? First of all, they wanted to encourage communication and interaction through glass walls instead of regular walls. Secondly, due to special slabs, they can reduce some columns inside a building. Not only this caused the reduction of the cost, but also they contributed to environmental protection by using less building materials. Third, by utilizing for all parts, there were no delays due to concrete curing time, and they were able to reduce the time dramatically. And finally, the presence of these structures made Apple Park feel like an expression of Apple's vision: simplicity.